Multiplication and division, an inverse relationship.
Hello everyone. Today we're going to talk about multiplication and division. First, we're going to start off with a little vocabulary. So when we're talking about multiplication and division, we're going to go into the concept. And to go into the concept, I'm going to use these diagrams here that I've created. So here is the whole. This is the entirety of the model that we're creating here. So within this whole, I have groups. And as you can see in this diagram, I have 1, 2, 3, 4 groups. And in this diagram over here, I have 2 groups. Now, within my groups is what is known as the size of the set. So within this group, I have 2, which completes the size of my set. And I have 2 more in my second set. Over here, I have 1. That is the size of my set. And I have 4 groups of 1, which combine to create my whole in its entirety. Now, how can we notate or represent this numerically? Well, this is multiplication. So here I have 1, which is the size of my set, or also known as my multiplicand, and I have my number of groups, 4, which is known as my multiplier. Over here, I have 2 in the size of my set, and I have 2 groups of 2. So that makes this 2 my multiplicand, and 2 is also my multiplier. So we're going to write and notate 1 times 4, or 4 groups of 1, equal 4, and 2 groups of 2, or 2 times 2, is also 4. Now, here, I've actually designed a game that I like to call circles and stars. And with circles and stars, what we want to do is take a die, regular die, and roll a random number. And for that, I have taken the liberty to already roll 2 random numbers. And the numbers I rolled were 6 and 4. And if I go in here, I'm going to notate the 6 I rolled in stars. 1, 2, 3, 6. In my second diagram, I rolled a 4. So I'm going to go ahead and fill in those stars. To get my product, or the result of a multiplication problem, I could go and count my units. 1, 2, 3, 4, 5, 6, all the way until I get to 24, or also what is known as 6 times 4, 24. I could do the same. I could count each individual star, but we know here that we have 12. 4 times 3 is 12. Now we're going to take this multiplication relationship that we've gone over, and we're going to inverse it, meaning we're going to go into division. So to do so, I'm going to borrow from the diagram we created with circles and stars and move into what we know as partition, or fair share division, which means how do we divide a number to be equally shared among another number. So our whole that we created is 24, or we have 4 sets of 6. And for a little context, let's say I have, 24 Tootsie Rolls and 4 friends, or 6 is the size of my set of Tootsie Rolls, and I have 4 in the group that I need to disperse them amongst. I can demonstrate this by simply drawing my friends. The stars represent my 24 Tootsie Rolls, and I know there are 6 Tootsie Rolls in each of my groups, and I can assign these Tootsie Rolls to each of my 4 friends. All of my friends get 6 Tootsie Rolls. If we were to communicate this in a measurement or rate, that means that there are 6 Tootsie Rolls per every 1 friend. Let's borrow the second diagram 4 times 3. For this illustration, I have 3 groups of 4. Now let's say that the 3 represents 3 plots of land that I intend to plant trees on, and I have 12 trees total, and I want to plant these trees equally amongst these lots. I know that I have 3 groups of 4, 3 plots of land, so that means each plot of land is going to get 4 trees, which makes my rate or measurement 4 trees per 1 lot.
We use multiplication and division in our daily lives, most likely more than we even realize. From when we're shopping at the grocery store to even professionally. Doctors writing prescriptions for patients, chefs recreating their own masterpieces, or fashion designers calculating how much fabric they need to design their new creation. So remember, practice your multiplication and division.